Okay, cool. All right, here I'm going to do a quick tutorial. Actually, I'm just going to wait a little bit. Just because YouTube kind of has like this weird latency period for streamers. Like maybe a 10-15 second lag that doesn't actually record. Okay, so welcome to this little tutorial I'm going to do. I should have done this earlier, just didn't get around to it because of college. On how to use the fCPU mod, which is pretty cool. It actually has this little miniature, I want to say, I don't quite want to say toy language, but it's kind of like it's like an educational, it's a more simplified educational version of assembly language. And this thing is really powerful. I mean, what you can do with like a zillion different combinators, which are a hell of a lot harder to debug, you can do with these little microcontrollers here, these fCPU microcontrollers. And apparently the developer actually added memory banks to this thing as well, so you can actually store things in memory, up to 4 of these things. And he also added, at the time he was like proposing this, now it's totally implemented, SIMD instructions. So basically you can operate upon entire array. So you can create an array and you can use one instruction to operate upon the whole array. So basically it's kind of like doing a for loop. Let me move over here so I don't have to listen to that. So basically, if you wanted to, you could just have multiple different things here. Say like you wanted to perform some kind of mathematical calculation or something on it, and just have it iterate or act upon an entire vector, an entire array of things. You can actually do that now with the SIMD instructions, but I'm not going to get into that right now. What I'm going to do is I'm going to just get people started with how to work with this stuff. So we're going to dive in. Supports blueprints too, surprisingly. I think that's a new one because I haven't worked with that much. Oh, supports blueprints as in you could blueprint the setups, I think, because I don't know of anything right now in terms of commands for directly manipulating or working with blueprints. You can use this with the blueprint deployer if you have the... Sorry, wrong one. If you have the blueprints, recursive blueprints mod, you can utilize the blueprint deployer in conjunction with this. So you have even more power with things. So anyways, first get started. I should probably go over things a little bit. Excuse me. What you can do here is first you have like a set of registers 1 through 8. There's nothing I can really do about that, the LTN network that's operating all the time here. What you can do here is you have these little registers you can pop in and pop out, so you can move data into the things, operate upon it, and then push it out to the output terminal. So right here, this is the most basic thing, is move. So you, goddamn thing, you move things to and from the registers. So, and with this you can thankfully also specify what the type is. So it's a lot better than, say, these darn things, where it's like, you only select type, you can use a constant, you can do something like that or whatever, and it's kind of vague, and it's a bit of a learning curve here, because it's simple once you figure it out, but it's not very easy to fully understand, whereas this thing is a lot easier to work with. Now, what I'll do is I will deploy one of these guys, get a thing here, get the thing to work. So what we'll first do is go to here, registers. This is like the default thing that was open. Actually, do the output buffer. An output buffer or input wire. There was not anywhere near as much stuff here. I don't think this... What's this called? Memory viewer. Yeah, I don't think that... Yeah, the memory viewer didn't even exist when I first started to work with this thing. which is really cool that you can now mess with this thing. So you can see what's being put out, what's being put in, whatnot. So I'll just go with this right here. So, see my little critters are being murdered here. Let's go with iron ore. I don't know. So, say we want to do some basic addition or something like that. You can do some trigonometry with things. You do all kinds of weird things of that nature. Come up with, I don't know, maybe a prime number or something. Something like that. So with your normal combinators, you know, God help you, where you have to specify, you have to have like a million different combinators to do something simple, like, say you have like one input dependent upon another input, so say, especially like the LTN, not LTN, but the logistics network, or say you have, what the hell? Throw this in here. Read contents. Okay, it's already reading the contents of what's in here. So yeah, it won't tell you what the filters are, but it will tell you what the contents of things are, including chests, regardless of if they're a logistics network or not. Don't worry, I'm going to edit this thing and make it better than me going off the cuff right now. So, I hate it when it defaults to Mem1 for some reason. This is a little pet peeve I've got right now. So anyways, in order to just get started with this thing, what you do is use the fig commands. Let me go here. So it'll tell you these right here are kind of useful, but this is kind of the basic syntax of it. Right here is in order to get inputs or to act upon the inputs that go into this device, what you need to do is you use the FIR and FIG commands. So find type in red-green wire, right? Input wire. So FIG is for green, FIR is for red. And what'll happen is it'll go through your inputs. There we go. It'll go through the inputs that are available. And you say, okay, I want to find, I'll tell you about this later on. I want to find like a given type, for example. So if you want to load a input here that's of, say, type iron, for example, you type in this command here, and what'll happen is it'll find an input of this type if available, and then it'll store it to the register that you specify. In this case, it's going to be the first register, or register 1, right? And then you hit play. Hit play or hit run, and they'll add that into it. One caveat I will have to tell you right now is that if say for example you're working with the AAI units or tile scanners or something, and it's variable as to whether or not the thing is going to put forth, say you're running like a tile scanner, for example, right? And you're looking for a tile that has, say, not a bug, but has like a biter nest on it or whatever. It's not a guarantee that you're going to have a biter nest icon coming out of one of these scanners every single iteration, because it'll be scanning. This is a unit scanner, but just bear with me. If there's a tile scanner that's going through all these different tiles, and you want this thing to find, say, like a biter signal, it's not, whenever there's not a bite, whenever you get like a false reading on it, if it doesn't find that type, it'll actually knock out the type of the register. So if you want to reserve a register, for example, dedicated to like a given type or something like that, or you want to say, fig find and add to. This is also a quicker way of writing it. So instead of reg1 or reg2, you can just say r2. Right here, say I'm going to do something here. Let's go with the Roboport, for example. Right. Actually, I'm going to put this thing on a loop. Hold on a sec. I'll get to this later on. P S. So as you can see, it's iterating here. So what I'm saying is, here's this section. I'm going to call it S for, this is called a label, where you start with a colon, then the label name. You have your contents underneath that label, and then at the end, if you don't have something like jump, it's just going to terminate. I'll just go through here and then stop. But what I'm doing here is that when it gets to this point, I'm going to say jump back to the start of label S. So basically it's a while loop. So it'll go from here, 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 and then when it hits the jump command, it says jump to label S, goes here. So now I'm iterating. And now what's happening is that every single iteration, it looks for an input for iron, it looks for an input for a Roboport, and if it finds a Roboport, I'll put it here. Finds iron, puts it here. Okay, so what I'm going to do now, just to demonstrate, that there. I just want to separate this out so it's not over complicated. You know what? I'm going to decrease the scan range here. I don't want to over specify. I want to come up with a huge distance for this thing to scan in. So I'm just going to put a Roboport next to this and specify a distance for low amount, probably like 10 or something. Okay, so as you can see, we're getting stuff like this. And it's going through this, it's going through the surface tile, like what surface is on the tile, what kind of tile, X and Y, coordinates, subtile, which is kind of pointless. Only for specialized applications do you really need subtile. Terrain type. In this case, it'd probably be the concrete, and so on and so forth. Surprised that it's not actually telling you what the hell the overlay is. I'm kind of surprised at that. Would have figured I would have been able to get that too. But in this case, it's actually just telling you what's underneath the overlay. In this case, it's just grass. And boy, they are already finding a happy little home for themselves. That was not intentional. Okay, so, oh, yeah, you just saw it. Every once in a while here under output signals on the right of the screen here, you'll see that Roboport pop up. Now, as you can tell, the Roboport is not a guarantee to show up here for each iteration. And I'll show you that that is a bit of an issue right now. So it's going to be going through here, and it'll be kind of hit and miss. So as you can see, once in a while it'll go through here, and as you can tell, the inputs here, the rate at which the inputs update is much faster than the rate at which this thing cycles. So that's one problem with the fCPU. So don't expect, if this thing's screaming at like light speed like it is now, that it's automatically just going to, in a blink of an eye, just catch the thing and pop it up here. Also, if you wanted to reserve this, if it does not find what you're looking for, it's not going to say, there we go, see that? When it finds it, it'll change the register to that, and I think it also updates the value. But if it doesn't find anything, if it doesn't find this Roboport in this case, it's just going to be blank. So you do have to be careful with that. So if you have a calculation or something in here that's dependent on working with the type, just remember that when you do FIG, you can end up wiping out the type in that register. Not just the value, but you can also wipe out the type here if it's not found when you use this FIG command. So that's just a little caveat to work with. Okay, so what we're going to do is I'm going to, oh, come on, go, autosave. I have this huge base, so things are a little on the slow side. The gripes of Factorio here. Gonna knock this out, knock that out, because I don't need that. Okay, so anyways, those are just some caveats I want to point out first and foremost. Now, what I'm going to do here is, let's take this out. What I'm going to do here is going to do just some basic arithmetic. So, this thing already found the input. Let's go back here to their inputs here. So, it found among the inputs something that matches that type, takes that input, puts it in, retains, copies the value into there. And now if you wanted to do, say, any arithmetic or whatever, it will operate upon a assembly type of thing here. So when it comes down to add, oh, okay, sorry. So you can do add like a normal thing here, except you have to remember that the output is not going to be on the right side, it's going to be on the left side here. Normal assembly language, you just get the coefficient that you're going to add something to, and your source or whatever is going to be the accumulator register. Okay, so with this thing, forgot about that because I play some other assembly language-based games. So basically, you could, if you want to add something to this register, or you want to use this as a coefficient to add to another register, you have to you can only act upon. Sorry. What I'm trying to say here is that if you want to do any mathematics or whatever that isn't from some arbitrary constant, you have to operate upon it using the registers. I don't even think you can use memory. I think you have to recall. I haven't worked with memory yet, but I'm pretty sure what you have to do if you want to work with memory is you have to move something from memory into a register and then operate upon the stuff that's here. So every calculation or whatever has to reference these. If you want to store any values or operate upon any values, it always has to be by address, referencing the address of the register instead of whatever's inside this or whatever your input is. You can't directly operate upon these. You have to load it into your register first. Okay, so enough of all these caveats and other stuff. Let's start adding things, right? So, what I'm going to do first is I'm going to just I'm not going to act directly upon this. What I'm going to do is I'm going to mess with a value. You can take this multiply it by a coefficient and store it into R2, right? So basic stuff here. So add, and then what's your destination, which is going to be register 2. I'm just going to have this so it's easier just to understand what I'm referring to instead of R2. We'll do that later on if you want to just say R2. But right now I'm just going to say, I don't know, maybe 20. Right? Register R2. And as you can see, it does not copy the value. But, wait, what the hell am I doing here? Sorry. Oh, right, okay. I'm thinking a little too far ahead here. Okay, so, yeah, it has to be based on you can't take a constant and add it to whatever. Sorry. So if I wanted to say add 100 and a coefficient of 20, right, and then store it into another register, what I would have to do first is specify, say, move 20 into the third register. Wow. Oh, sorry, I'm used to another syntax here. I'm thinking about TIS 100, guys, sorry. Which is from Zachtronics on Steam. Yeah, this is how it should actually be, is where the destination is first and then the coefficient is second. Okay, so here, 2, I think? I don't know. So what I'm doing here is I'm moving 20 into this thing here, and then what I'm going to do is I'm going to add 2 together, and in this case it's going to add 20 to this one here. Let me just get rid of this because this is actually confusing. Okay, so what I'm going to do, so what's happening here is I'm going to, let me just make sure oh, crap. Clear. Okay, thought so. So, V, or 20. Okay, so what's going to happen is I'm going to move 20 into this, and then in order to add say 20 to this register, first you have to move 20 into another register, and then add the 2 together. So what will happen here is I'll move 20 into this one, then I'll load this input into register 1, okay? And then I'll add the 2 together. So what'll happen is I'll take this register, add it to this register, and the result is going to be stored here in the source. So when you do an addition, you can't specify a third value. It has to be one of the 2. And the one that's going to be the destination is going to be your first coefficient when you do add or any other kind of binary operation. So now we have 120 instead of whatever. So of course you might be thinking, okay, well, what the heck's the point behind that? Well, I'm sure some people have already figured out kind of the kind of things they would want to do. Thank God I have a high amount of shields. Say if you have like your LTN or something like that, or you just want to measure the difference of things. Say you want to specify in advance, like you want to say you want to figure out automatically what the difference is going to be here. Say, so you have like a total right now would be. Just thinking about the stack size here. The storage is telling me how many there is per stack. So say the cap of this thing would be 90,000, right? And you want to find out how much storage is freely available, right? And in order to operate, say if the difference is like below a certain amount, you know, put out a request or something like that to the LTN. And that's where you would use something like this without having to build a zillion different combinators. So say for example, R2 is 90,000, and you have the amount that would be stored inside a warehouse, right? Which would be emulated by this green input wire. By this right here, say for example, would be your warehouse or whatever your storage unit is, of how much you currently have. Here would be your cap, and then you would say sub that thing, right? So you have 90,000, which is your total amounts, and out of the 90,000 available, how much oh crap, no wonder. Actually, I take that back. You actually would have to negate this. So actually, no, that's pretty good there if you want to load that into the LTN, because that's going to tell you how much is needed. So this is actually a good way of doing things. So say you have like a total capacity of 90,000, you only have like 100 that's currently in there, and in order to fill it up, you know, your demand or whatever that you would send to the LTN would be this amount, right? So it says I have a need, currently I need 89,000 units of iron, and of course the negative value will say that I need this much, please give me some from wherever has a positive value, which is where LTN, Logistic Trade Network, usually does. So you do this sort of thing. Of course, this is kind of like a basic binary operation. You don't usually use these by themselves. You want to, because otherwise you could just use a simple arithmetic combinator for that sort of thing. But where this kind of thing shines is if you have multiple different things to operate upon, or most of all if you're working with like AAI, for example, which I have set up over here. Do I have my little plane here? No, I do not have my little plane here. Okay, do I have a vehicle I could quick slap down? Yeah. Oh, hell no. Sorry about this, folks. I have some haulers up north, but by the time I go all the way up there, even though I have a teleporter here and come back, I just do this. Okay, so we have our little thingamajig. And of course it's going to be loud and annoying. Okay, so unit ID 84, not exactly important. What you have to remember here is the unit ID number, which in this case is going to be 5. And what I'm going to do is I'm going to say, I put a number here. Okay, so scanning through all the numbers. Okay, is this thing really scanning through every single unit hauler and finding the one that actually equals 5? Or did I mess with the pulse frequency? I messed with the pulse frequency. Of course I messed with the pulse frequency. Here we go. So this is all the stats of this hauler. So if you're already familiar with AAI, just bear with me. As you can see, all the stuff that's popping up over here tells you where it's located, the subunit, the stuff that's inside of it, and so on and so forth. Now, if you wanted to move this thing, say you wanted to automate where you want this thing to go, granted you can of course use a path controller to set up a set of waypoints for this thing to go in a circuit, or to go from one point to another as a one-way, or just go in a loop. You could do that. However, if you want to do something more advanced, or do something that's based upon calculations, this can turn into a rat's nest real quick of using decider and arithmetic combinators. So what you can do with this guy instead, right now I have that, this guy right here. Okay, so I have that input. Now what I did here is I got the inputs here. I say it's already moving it. No! You didn't run! Don't run, damn you! That's fine. It doesn't matter if this thing is like on the other side of the map, as long as I have the ID of the thing. Oh dear God! I want to see where this derpy thing's going. Hope it doesn't get run over by a train. No! Come back! Come back! Okay, the moment that thing... Okay, we're going to do this quick. Because the moment this thing gets to here, that unit controller is going to tell it to go back to Timbuktu. Okay. Oh, this is fun. So, basically what's going on here is, if this thing has a low enough amount of fuel, move to the refueling location. In this case, it's hardwired, so I have my X is just going to be 30, and my Y is going to be 334. That's going to be a coordinate somewhere on here. I'm going to replace that with this guy so the thing doesn't get run over by a friggin' train, which is going to be negative 195, negative 36. Okay. Hold on. 195. Okay, just do that. What the hell? Okay. Oh, no. How did that get destroyed? Okay, I'm gonna explain this after I put this in because I don't want this thing to kill itself by getting run over by a freaking train. X here. Okay, here we go. Is it really saying 36? Oh, God. Whatever. I don't know. Don't worry, I'll be fine. Until this disappears. Then we know it's dead. Or this disappears, we'll know it's dead. So what's going on here is I'm telling this thing to find any kind of stats in here that matches jet fuel. In this case, it's not powered by jet fuel. It's powered by God only knows what got thrown in here. Actually, wait. Is it? I forget what the hell I threw in this thing. Oh, this is only going to look at the cargo, not what's in the fuel slot. So if you have, if the amount of fuel that you have in here doesn't extend into the storage compartment, it won't show up. I think what will show up is fuel gauge or something. I think one of these is the fuel gauge or something. I don't know. But anyway, for right now, what I'm doing here is loading these things into the input. And if you want to pre-specify something, right, if you're not going to load something directly into here, which I probably could do with FIG, but if you want to specify something ahead of time, like I'm doing with this, because the coefficients here aren't going to be coming from this. This right here are just going to be hardwired destination values for the refueling point. So what I'm doing here, in order to specify what type of thing I want to send to this unit controller, in this case coordinates, I say SST, which is specify subtype. I mean, it says specify whatever the heck type. So SST is, oh yes, set signal type. That's what SST stands for, set signal type. And SSV would be set signal value. Okay, so what I'm doing right here is, okay, sorry about that. What this is doing is it's actually getting the distance? What the hell is this thing doing? This is an old script here, but what I'm doing with this is I'm moving the why am I doing this right here? Let me change this up. So for this example, this is the better way of doing it. Okay, so there we go, and it's retaining its sign. Okay, so it does take in negative values. All right, so what I'm telling this thing right here is that these are the coordinates for where I want this thing to go. Okay. And I think I'm just going to get rid of this crap right here. But, yeah. Ooh. Okay. So what I'm telling this thing to do right now is to go to this location. So what I'm doing here is, in order to tell this thing where to go, you have to tell it, you have to give the X and Y coordinates, you have to feed that into the unit controller for AAI. So what I'm doing here is that you have to tell it, you have to specify what the register type is going to be. So you set your X and your Y types in here so it recognizes it as a location instead of just some random constant. And then I set the constant values with SSV. So set signal value, which is the value here, and set signal type is the X coordinate. And then once you have all this stuff set up, right, this is all defined, then what I'm telling this thing is I'm sending the ID value of the vehicle, which I tell the unit controller, okay, move this vehicle with, not just any hauler, but hauler number 5, hauler ID number 5, to these coordinates. And the way you tell it to the way you specify your outputs right here is through the move commands. So my move, you say move out, and usually the outputs have to be numbered. According to the tutorial, to this Informatron thing, you just need to say out, or actually emit. Hopefully it's been fixed, but the last time I checked, emit doesn't actually work. So what I do is I just specify the output. So the output for slot 1, this would be output 1. And as you can see, it's just labeled here. 4, 5, 6, how many outputs does the damn thing take in? I think it's like 250. Yep, 256 outputs. So you can specify as many as 256 signals being pumped out of this thing. And the way you do that, where you specify where your output's going to be, is you move a register value, in this case, the ID value of this thing, to output 1. So you want to say, okay, my type is going to be in output 1. This thing doesn't care which place this thing's in it. This could be over here, this could be over here. Doesn't matter as long as this thing gets the 3 magic numbers of what it's going to be moving and where it's going to be moving it to. So what you're doing with the move here is you're saying, okay, move this signal, to the output, move this signal to another output, this one right here to this output, and move this signal to, this one right here to this output. And once you do that, the intrepid creation that is probably off, God only knows where by now, is supposed to go there. Is this it? No, that's not it. Ah. Yes, go creature. Okay, now we just have to find out where the hell that thing ran off to. Okay, so that's how you do it. At least. This derpy thing is either going to be murdered by a train in cold blood, or it's going to show up here at some random inopportune time. Just you watch. Where the hell did I send that thing? Okay, these are ones that I already specified. Oh wait, there are actually little red arrows here. Let me quick scan around here. Where did you run off to? Where did you come from? Where did you go? Did you die horribly? Chances are the goddamn thing is over here somewhere. No, just where that one's there where it should be. It's gonna feel, that one's gonna feel, that one's gonna feel. You know what? Hold on a second. ID 1. So if you want to change the ID, of course, it's going to be pretty easy. Just change the coefficient. And in this case, it's going to be, I'm doing it from the constant combinator, so I knew for sure which one it was going to be. Ying. Okay, so now we're going to be moving something from a location that we know, provided the AI is turned on. The AI is turned on. Here we go! It just had to find its path. Alright, just had to calculate the path here. And now it is automatically moving to this little marker right here. Because it's moving to the coordinates that this marker is specifying. Q. So there it is, and let's see if it gets trash. Because that's probably going to happen by the time the damn thing gets here. And they are pretty derpy, man. The pathfinding in this game is not the greatest. But hey, it's powered by jet fuel, so... Better derp than never. Okay, kill you, tree. Alright, so that's how you can use this thing for a simple movement command. Of course, what I was doing before with this other script was calculating the distance or something like that. So that if it was within a certain distance, based on the fuel. So if the thing was low on fuel and it was, I don't know, X amount of distance away, it would select like what the destination would be. You can do that with this thing. So that's what I was dealing with this here before. First sub. Okay, what I'm saying with this right here is if this was originally for the cargo plane, so if the cargo plane was below a certain amount, you know, move whatever the heck out to it. Anyways, so so you have these basic things, swap signals in and out of the memory cells. This is how you interact with your memory. Is you could store a whole bunch of other stuff in your memory cells, but if you want to act upon it, it has to be put through a register. You can't directly act upon it, which is similar to a cache and a CPU. Just like like a normal CPU or a processor, just like in your computer, it can only act upon what's in the registers. This would be your cache. So if you want to calculate something that's in the cache, you got to first move it into the register. And you got 4 of these things to work with, which is pretty cool. Those did not exist before. It's kind of redundant to have it that way. And here's the output buffer. Probably going to disappear when I click it again. Yeah. Okay, so that's how you do that. Branching is going to be the next thing. These are new ones here. Before it was just plain flow control. There we go, for jump. And testing operand values, testing operand types. So what you do here is that if you want to have your conditions, like basically this is what you would do for if statements. So if one value is, say, equal to another value, do what's below it. Otherwise, it's going to skip to the value afterward. So it's going to say... I don't know. I don't even have to really bother with this right here. And I'm just going to say like 90 or something less insanely high. There we go, something like that. So what I'm going to do here is going to do this. I'm going to just come up with some little pet thing here. So I'm going to say, let's see what I have first. Okay, so I'm having these 2 registers. I specify a constant into this register and have this little variable here from this grid input wire, right? So what I'm going to do is I'm going to say, like, if this is bigger or lesser than this right here, like the amount of iron that I have, calculate the difference. Otherwise, just, output, this right here as is. So what I'm going to do is I'm going to say test greater than TGT, and the order does not matter. Well, the order does matter. Say, what I'm going to do is I'm going to say if R1 is greater than R2, so if this here is greater than this, do this. If not, then just output, I don't know, like actually move this to, I gotta say what the destination is first. And say move this out to, move from like R1 to the output buffer, right? And yeah, okay. So this is actually a pretty interesting one. This is ambiguous to some degree too. So what'll happen here is it's gonna load this into memory, and it's going to check if this is bigger than this, and if it is, it's going to subtract those values, put the difference in here, and then it's going to go to the next instruction. Now, if that was false, if R2 is equal or R2 is greater than R1, so if this was greater than this, it would skip this and then go to the next instruction. Right? So it's going to move this, it's going to output this regardless. And of course you can get around that, you can add different flow control stuff for your jump statements or whatever, but this is just going to be a test example. So I'm going to move these two in here, right? And then I'm going to say, check if R1 is greater than R2. If so, as you can see, the blue cursor here moved from 7 to this. So this was true. And since it's true, it goes to the line just below it. And then executes this instruction. And then it does that, takes the difference between register 1 and register 2, R1 and R2. These are the same, just different, it's a shortcut or nickname. And then it outputs it into register 1, because that's the first coefficient here. The first argument. So it takes the difference between, it's basically saying this minus this, and then save it here. Now, after that, you have 10 remaining. And now it's saying move this to the output. Bing. Okay, so now, if I look at it, it's not showing the thing, which is kind of bizarre. But if you... I'm just going to put that right there for now. Do it right there. So it doesn't say it here when you do a mouse over. It only shows you the input signals over here. But you can tell the output is actually outputting that signal of 10 iron, your result. And it doesn't actually matter what color it's going to be. The output's an output regardless. So this way you can have, say, like this and this. Say it's like, okay, I only want this to operate upon the crap that's being piped out through green, and I want the stuff that's being piped out through red. Right? So, yeah. So that way, if you only want to operate upon a certain thing, you have that going on. It just helps with selectivity. And yeah, get rid of red. No, I don't want to do that. Yeah. So just like a normal combinator, you can do your little feedback loops and other stuff here too. So that also allows you to do some stuff in memory or whatever you want to do. Now, if on the other hand, I'm going to do this so that it's false, right? So now I'm going to show you the case in which this is false, right? So if this is actually greater than this will fail, and it'll just skip down to here. So now what I'm going to do is I'm testing if R1 is greater than this, and in this case it's not. So as you can see, it just skips from here directly down to here. It does not ever touch the line directly below it. So in this case, it's going to move this directly into the output buffer. There you go. So it doesn't do any arithmetic, it doesn't do any calculations, it just says, okay, well, don't do anything, skip this stuff and do this. Now, you might be thinking, okay, well, that's great and wonderful if I only have one line of stuff here. What if I want to put forth some squirrely function or something like that? I want to do like this whole bunch of things in here, right? Well, what you can do is you can create yourself a label, func, because it's funky. So, I don't know, add, say, I don't know, 30 or some arbitrary nonsense, and then sub R2 50, and then adds 1 at R2 to R1, get the results, and then whatever. So what's going to happen here with these jump commands, what I'm going to do here is I'm just going to wipe this out. So what I'm doing here is instead of doing just one little command, what I'm going to do is I'm going to say if this is true, go to this section, which is going to cause the cursor to go from here to here, and it's going to start executing this stuff. And the thing is that it won't, unless you specify where to go, afterward it'll just terminate here. Or if you want this to, if you want this to not be a dead end, then you just put through another jump command. In this case, jump S to return to the top. So if you want like a little thing here of like, if one's greater than the other, do this stuff. If not, just like spit it out. And of course, unfortunately, you have a little bit of redundancy because this will not be executed if you jump from here to here, unless of course you have like a label here for resume. In which case, if this is true, it'll go to this right here. If not, it'll just go to here. I mean, it'll skip past this. It'll treat it as a label. This won't get executed, but it'll just go from here to here if this is true. So let's just demonstrate that so it's a bit easier to understand what the hell I'm saying. So first it's going to test if this is greater than this. In this case, no. It's just going to pump the thing out. So what if it is true? In this case, it is the case that this is greater than this. So what we're going to do is going to do a jump. Okay, so if this is true, go to this function. So it goes down here. And first it's going to say, okay, add 30 to this, right? And then subtract 50 from this register right here. So you get 30. And then you add this to this, and then you get your total of like 160 or something. And this is just some arbitrary calculation to give you an idea of what's going on. And then you take that result from this register, or you could take whatever other register, you just specify what it's going to be, and then you move that out. So you put out that signal. Now it's putting that out right now, right over here. Now, of course, if you don't want the redundancy, you can put in something like this jump command, which is just going to cause the thing to go back over to here, where you have that, which would be common to both of these. So instead of having to rewrite this twice, like you see right here, if I do something like this, that'll return it to the line just below, the if true statement. I don't have to do this stuff. Because what will happen is it'll go back right here. Say jump to, label res for resume. Goes to this label, nothing, no instructions or anything are here. Just to let you know, you can put instructions directly after the label. It's no big deal. So right now it goes to this label, it's like, okay, nothing here, go to the next line. Okay, so what am I going to do? I'm going to take all the stuff from R1 and move it to output 1. In this case, it's kind of redundant because we already did that, but just to give you an idea what's going on. So, I'm going to show you what it does. This is a little recap. It does all these operations, adds one to the other, and in this case, you don't have to worry about it moving the output being here twice. You don't have to write that twice because it'll just do it here. So even if this thing is false, of course, I know it's not redundant here, but I just want to. What the hell did I just do? Oh, there we go. Okay, so this failed, right? Yeah, sorry about that. I go to clear. So, okay, we load the two things into the register, test it, and of course this test is going to fail because 100 is not greater than 120, regardless of the types. You can compare types, by the way, but yeah, here we go, types. So if the types are the same or if the types are different, right? You can't say one type is greater than the other. It's just a Boolean, whether it is like this type A is equal to type B, or it's not. That's all you have for your types, of course. Now, of course, with your operand, when you're dealing with values, you're dealing with integers typically, so you can have a lot more freedom to do things. Anyway, so this is going to fail. 100 is not greater than 920. Goes through and it's like, okay, yeah, no, don't jump to this function, skip that, and just output your 100. So, yeah. Okay. Apologize if that was too long or drawn out or whatever. Okay, so there's these little bit shift things. I mean, you can do this if you're really into this sort of thing. I don't really recommend it unless you are into like computer science or you know how to screw around with this stuff. Usually just, stick to like the basics of arithmetic is all you're going to really need. Find type, like FIM is the equivalent of FIR or FIG for your memory banks, if you want to load something into memory. And in order to, register 1, register 2, signal values in memory cells. It's only specifying registers in here, notice that. So yeah, this is usually this is all you're going to have to do. Get the fraction part of a real number and register. Yep, so you can do your floor, seal, rounds. You can calculate the distance, which is... Oh, set the digits, sorry. This right here is interesting, so that if you have like multiple encodings, this is something you would do if you want to have a... like DGT would be, say... Oh, I don't know, you have like multiple different variables or something, or you just want to compress it. You don't really have to do it with this, but just for the sake of argument, if you... Do I really want to destroy this thing? Yeah, what the hell, let's wipe this thing out off the face of the earth. So, say you have a bunch of codes or something like that. And this isn't gonna... Let me get this... No! Don't die on me! Why? Okay. Technical difficulties. I think it's because the thing was running. And I wiped it out. Ah, crap. Okay, sometimes it gets a little sensitive. Come on, Machino. Okay, so die. Maybe that's what I have to do. Okay. Please don't die. Please don't die. Please don't die. Please don't die. Good. Okay, cool. So we're good. So anyways, say, for like flow control or something, or you just want to shorten, like, say there's this mode or this status or whatever for like, say one type, there's like, a 4 here, like, say there's like 4 inputs of one thing is available and, 5 of some other damn thing is going on and like 8 of whatever. So instead of having like to load different values, instead of having to say like move to R1, actually you would have to say SSV. This is kind of an SST4. So instead of having to say for this register, actually you don't even need to specify the type. Instead of saying, okay, I want 4 in register 1, this 5 in register 2, 8 in register 3. What you can do is you just have this little thing here, and if you want to operate upon each value that's in here, as long as it's less than 10, especially for like flow control and like little status numbers you want to assign to things. If you want to just operate upon these things that are having to specify all this other crap, saying put on a bunch of move commands and whatnot, what you can do is you can say set digit and get digit, right? Get digit number from destination and write to DST. So to destination. So In this case, it can be constant, so you can actually specify the number outright. You have your register here or an input, so it doesn't read from memory. Like I said before, you got to load it into register usually. So in this case, I want to say test if equals, say, you know, are there four of, like, you know, what the hell am I doing here? Oh, right. So get digit R2. Get this. Wait. Used to something else here. So you put in your number, which in this case is going to be a register, and you put the digit of that number. Oh, okay, you're specifying, oh, the digit right here. Or am I thinking of something completely different? Hold on a sec. Oh, wait. Where the hell is this thing? Sorry, folks. Oh, the joys of being a live streamer. Oh, holy crap, that's not a great idea, but okay. Okay, so this is kind of destructive, but... Okay, so if I only want to read... So the way this thing goes is that out of this entire number, say you only wanted one digit out of it, so in this case 4. So like out of this number that goes into it, you know, what do I want for the 100's place, 1's place, the 10's place, right? So if I wanted the first digit, just say dig R11, and unfortunately the darn thing is going to wipe out the whole rest of this information, which I'm not really crazy about. I was kind of hoping it would be something not quite that insane. But, sorry, it's going, God, it's going to start from here and go to here. Yeah, that makes a lot more sense in terms of 10 to the whatever power. So in this case, it's going to be the third digit from the right, not how you view it. All right. So here we go. Just to clear it again, so we move this into here. Try and get number 4, which is the third digit from the right, and then we get that. So it's kind of interesting, especially if you have like a large number or something. I could also see this being helpful for dealing with larger numbers. So you don't want to have like 90,000 or some stupid thing like that. If you're only concerned about like say that or whatever, say you know that you know you have this amount or whatever, you're just concerned with, you know, this or whatever. So say the thing would only go, the thing's like less than 1,000,000 or whatever, and you just want to know if it's less than some amount, and you don't want to calculate all this other crap here, or specify these giant registers, or make it easier to put other stuff in here to manipulate an otherwise large number. You can just select that. Hello. Yeah. Oh, right, yeah, 4. I'm like, oh yeah, why is it saying 6 and it says 4? Yeah, never mind. Yep, so we did get the right one here. And of course you can manipulate this as well. What's the mnemonic? I forget the mnemonic, DIS. So you're setting, yeah. You're just specifying your digit and you're gonna rewrite the thing. If only this thing allowed a tertiary argument, this would be so much more useful because then you wouldn't have to worry about destroying the damn thing. You know, but I don't know. So that's how you can mess around with this thing. And I'm not going to really specify, I'm not really going to like demonstrate how all these other things are used because it's kind of, I mean, as long as you have a basic understanding of arithmetic, you know, you can just set these whole things together. Although order of operations, maybe I could. It's not like you're dealing with the parentheses or anything. It's like the order in which you list things is the order in which things are executed. So if you say like multiply, add, divide, whatever, it's not going to go multiply, divide, and then add. You know, it's not going to go from this line to say this line if this was divide to add or something like that if that was this line. It's going to go, you know, this line, this line, this line. So order of operations is irrelevant when you're dealing with this kind of language. Oh, and you also assign random values too. That's kind of interesting. Yep. And, huh. Okay. Also, for Modulo, apparently he added these, instead of just playing, I guess these are supposed to give you floats or something? That's kind of interesting. So mod here is Modulo, and apparently this right here is for integers. So instead of giving you like a decimal or some kind of fraction, you're only getting like the rounded to the nearest whole number or something like that for mod I. So you're only getting whole values instead of like the whole value along with some kind of decimal or some crap when you get some like mod or div or whatever. Yeah, it is helpful. And then you get your trigonometry and stuff if you want to deal with like distances or you know, usually something of that nature, or you want to go like really overboard with some kind of I don't know, mathematical programming or optimization or God only knows what. You could do that possibly, or artillery manipulate. Yeah, targeting with artillery is a possible way of dealing with this as well. Or you actually want to get your hands super dirty and not work with the path remote controller and actually tell the thing, you know, turn this amount and then move this amount, or you know, if you're really insanely particular about how you want your units to move. You know, if you have like control over your vehicles or something, you can do that. But yeah, these right here are like for interrupts and whatnot. So you know, halt or stop the execution of things until some criteria is met. So on this one, it's BKG, block until there are at least, you know, so and so red green signals. This is actually pretty useful. So, and the above, the last example that I showed you, where you don't have like a guarantee. Where the hell? Yeah, right. I destroyed the thing because it eats up UPS. Actually, you know what? I'm just gonna say, yeah, grab you. Don't quite have a manufacturer on these damn things. Really? Yeah. No. Okay. I wiped out the combinator that had the distance in it too. Figure I could have cannibalized that. Okay. Whatever. So in the previous example, you have this, right? And you want to select something out of here that isn't always going to be available. So in this case, you have, I'd say 7 things that are showing up here. But who the hell really cares about this stuff if you're only concerned about entities? Or current zone or some crap like that. So that really cuts things down a bit, right? So by default, unless there is some kind of unit that's being detected, it usually doesn't go over 3 tiles, right? In this case, 3 output signals. Seal. So just going to put in clear. Although you might not want to do this sometimes if you're running a loop and you just want to have I mean, usually you do this right here, unless of course you want to specify a certain amount of types and you don't want that getting wiped out. I don't know. But I'm just going to do this for the purpose of this thing. I'm just going to use CLR to wipe out any stuff from a previous iteration. So block signals, I think. No, yeah, BKG until a certain count, right? So don't run this thing until there are at least 4 signals. So that way, when it's running through when you're scanning tiles like this that have absolutely nothing that could possibly be a positive, just ignore that shit, right? So say 4. That way it doesn't go for this crazy nonsense, right? And then fig, because the thing's gonna be under a green wire. That's gonna be the input, and then you can start to look for whatever your heart desires. Let's come up with something unique. You know what? Might as well just go for the circuit pole, as ignoble as that thing is. Alrighty. So as you can see, I was about to say this is a little slow. I don't know. So actually, let's put. It's actually going to be better if I just throw something with a larger footprint down. Okay, put that sucker down. Do it just like before. That one example. So what I'm going to do here is going to show how to select this without going through too many iterations that are pretty much worthless, right? And that way you can basically increase your chances of this thing actually catching this out of all the rest of this dross, right? So we're going to say if you find this thingamajig per scan, pop it in here, and then fig. Say you want to get the coordinates of this hocus pocus. So you're looking for, say you want to look for an object and you want to find where said object is located within this given area, which is useful because you can actually modify the distance. I don't think Neilhouse talked about that with his AI tutorial, but you can in fact offset these things. So if you put in an X and Y coordinate in addition to your distance signal, what it'll do is it'll calculate the distance from that location. So if I specified wherever the hell this thing would be located, or if I specified these X and Y coordinates, instead of calculating, instead of checking all the tiles within a 10 tile radius of this thing right here, it would check all tiles within a 10 tile radius of this thing, or this location rather, if you put down your X and your Y. So that's kind of an interesting little aside right there, but I'm not going to be working with that since I already have this stuff over here. So let's just, I don't know, just load in the X and whatever here. And I don't really need to clear the thing, but so I'll just say S and just use the basic while loop. So just keep iterating through the thing. Don't really do anything other than just find and upload the values. Right? Boom. So what's going on here is there are other objects. Right? Or at least in theory, that's what the hell should be going on here. Oh, man, it'd be a long enough time to put in an advertisement. Okay, get out of the way. Anyways. I'm just wondering here if this thing is up, if this is literally updating every time it gets an input, or every time there's a damn input wire here going on. Otherwise, oh, okay. Wait. No, BKG is fine. Okay, so there's two different blocking operations. One is for red, which is BKR, and the other one is for BKG. And in this case, I'm dealing with a green input wire, so that should be working fine. And this thing is running at the speed of light, basically. What do you want, kitty? Sorry, the cat's over here meowing. I already gave you food. Okay, you just want to lay down, let me know that you're over here? Okay, that's cool. Oh my god, I mentioned the cat and the dog comes over. So these things are changing. You know what? I'm going to say FIG. Yes, Layla, I love you too, damn dog. Yes, I'm trying to work the keyboard here while streaming. Thank you very much. Ah, what the hell? My cord here is getting caught up on something. Okay. Yes, Poochie, I love you too. Yes. Okay. And let Daddy work. Let Daddy do his broadcast thingy, okay? You want to go underneath the desk? Okay, good. Ah! Yanking on the damn headphone wire. Okay, good girl. Yes, I love you too. You just stay there, okay? Good girl. Be good. Don't pull on the damn wire or something. Ooh, sorry, girl. Here you go. Yes, good girl. Okay. Sorry about that. Okadokadok. So, in this case, I'm not going to need an FIG. Let's see. Move outputs. Let me just check this out to see what the hell is going on here. Because I hope that this thing is not reading inputs, even if there isn't more than if there is, even if there's only 3 or fewer signals than what this thing's supposed to be blocking it from doing. God damn it, it is. So even if there's only 3 signals, the damn thing doesn't work. This is kind of strange because it is pausing around 3. Oh, you know what's going on? Oh, this is not good though. So what's going on right now? Okay, I realize why the first register doesn't always have something in it. And the reason why is that this thing waits until there are 4 signals here, and then 1 tick later, the damn thing goes to check the green wires. So if there's 4 signals on 1 tick right here, right? If there's 4 signals, this will be like okay, and then it'll check here, but it'll be on the next tick. So this can trigger when there's 4 signals, and then by the time it gets to this, that condition is already passed. It's like checking another tile. All right, let's remedy that by slowing down things. Hold up. I was hoping this wouldn't happen. Okay, so the sampling, of course, is going to be lowered because it's not updating that often. The thing with the, this isn't a problem with the microcontroller. What the problem is that this thing only outputs every so many frames, so many ticks. So in this case, it's going to be four, yeah, 4/60ths of a second. Every 4/60ths of a second, it's going to pulse. But then when it's not pulsing, it's just going to display absolutely nothing. It's going to be a total blank. That's good if you're like reading things, if you have like a little counter here or something, but definitely not for something like this. There is a remedy for that though. Yes, I know. What the hell is wrong with it this time? One sec. Okay, the way this thing is supposed to... Ah, that's why. Gotcha. Okay, so the way I had this thing set up is that what it'll do is, instead of having to worry about this thing basically having an epileptic seizure, if I want to store a value long enough that this thing can pick it up, what I'll do is I have this little contraption here. And unfortunately this doesn't have as fast of a tick rate, so I have to use some combinators, unfortunately. But what will happen is that if I want a value, right? It'll grab one of these things, at least in theory. What kind of crack is this thing smoking? Okay, I gotta review the circuit, sorry. Okay, that's kind of... Okay, this is... Never mind. I have to go back and revamp this thing. I wasn't using it for an fCPU circuit. That was something else in the sandbox I was messing around with. So, anyway. Sorry about that. So yeah, this is going to take a little bit of screwing around with. You have to have a memory circuit that holds the value long enough that this thing will catch on to it. Because unfortunately, the update speed is not the greatest thing on the face of the earth. Okay. So we have the testing, we have the operands. I'm not going to go quite into the SIMD stuff yet because I have to mess around with, there we go, arrays. So I'd have to do that, but that's pretty useful stuff. So right now I kind of did the basics here. I'm going to start another stream and come back with more preparedness or whatever, and it's going to be a lot better than this kind of prototype thing here. Let's see. Signal value register. I'm just like, okay, yeah, pretty much everything's been covered here. Covered labels. One or more could be specified multiple times with a space separator. What the hell? I don't know how the hell this one is supposed to be used. Unfortunately, it doesn't give any use cases. Optional may be specified. I guess if that's, you're going to specify what kind of registers or a thing to move the hell in there. Or more and more move commands. I don't know if this is in relation to particular variables or the line, the commands themselves, because there's a big difference between those two. Should ask him. To access one cell. Oh yeah, memory here. Let me see. Interesting. Oh, okay, this is new little thing in here. Okay, so, okay, yeah, the number of signals, I can understand that, but the clock value increases every tick. Yeah, well, it doesn't exactly increase every tick. Or actually, maybe the instructions move it once every tick, but unfortunately the damn, something like this isn't super friendly with fCPU. You have to you kind of have to hold. You have to do a sample and hold circuit is essentially what you need for something like this. If you want to work with something that updates this fast, you need a sample and hold circuit for this thing to read it. And of course, the sample controller would be based on the output from this thing, and the hold circuit would be if it's the sample is off versus when it's on, it'll read it. But, yeah. Okay, now that'll be for later on. Just checking here. Okay, so I think we went over the basics. I'm going to chop this darn thing up into something that is going to be presentable on YouTube. If you have been watching, thanks for watching. I have a pretty small channel, though. I think it's like 12 people on this thing, so I'm not really concerned with dragging on too badly for this video, at least, because nobody's probably watching it. But yeah, later on, this will be... I'm going to be more prepared and actually bring this stuff together, so... Yeah. Alright, well, thank you for watching the stream. The recording of the stream, rather. And stay tuned for me to actually turn this into something palatable. And something that you can actually stay and watch for a decent amount of time without spending forever. And yeah, I think I'm also going to probably redo this in a more short and sweet way where I have a bunch of circuits already worked out here and show people the whole 9 yards and then send this to ConSTG. That's the username of the guy that designed this awesome thing. I really love this here, but just kind of winged it this time because I'm also testing out the YouTube streaming platform as well, because unfortunately Twitch is not recording my friggin' videos that I stream to it. So anyways, do not want to drag on any further. Thank you for watching, and I will see what I can do later on since I am on my winter break, and I can pretty much afford to go over cool stuff like this. Alright, thanks for watching, and goodbye.